minus 6, 5, 4, 3, 2, 1.
Cloud instances also require data protection. With vProtect, you can create backups and store them outside AWS Cloud. Let me show you in this short video how to do that. First, I'm logging into vProtect console. This particular instance actually is installed in the AWS. I have two virtual machines here. One is actually the vProtect node with vProtect server installed also in the same environment. The other one is the instance that I would like to protect. Now, in the dashboard, we actually have many different sources types available. You can notice that we have virtual environments, applications, and storage. From the AWS perspective, actually we treated everything as a virtual environment. In Virtual Environments tab, I have these two instances visible. The very first step usually is to add account to your AWS credentials. You create Hypervisor Manager in this case, provide your account ID, access key and secret key. Now there are two options which also allow vProtect to store the Windows-based deployment, is to also to create an image, any image that is going to be used later during the restore process. This is especially important from the licensing point of view. Optional, you can enable this as well with the Linux-based deployments. Now, once you have defined the Hypervisor Manager in this case, you usually initiate inventory synchronization, a process that collects the information about available instances in your environment. With vProtect nodes, you will have to deploy actually one node per region, so that the data is not transferred between the regions unnecessarily. Now the inventory synchronization task has completed. Notice that in the instances view, I have actually still the same set of the instances. Let me initiate the full backup on one of my instances. This also creates a task. This one is an export task. vProtect allows to stage the backups and later push data to any other backup provider that we support. You don't have to store your backups only within the AWS S3. You can also store them on the file system if you would like to use the one that is provided with vProtect, but you can also choose between several enterprise-grade backup providers that we support. That includes IBM Spectrum Protect, Veritas NetBackup, Dell EMC Avamar, and Dell Networker. Export process dumps data directly from your instance, so that means attaches the snapshotted volumes from in the cloud and dumps data to the staging space, where from this place it can be uploaded to any backup provider. Inside the instance details, notice that I have my backup restore statistics, like the daily activity. Especially useful is also the tab that shows you backup sizes chart, backup time charts, which also helps you to track if there are some bottlenecks, and overall transfer rate in this particular backup. At the bottom, notice that I have two backups available, several already more in the history, and I have restored some of my backups earlier. Currently, I have one snapshot on this particular instance, the one that is going actually to be used to create this backup that is currently running. My instance has only one disk, and we also have mounted backups of this virtual machine available. For the AWS, we also support Snapshot Management policy, which allows you to create periodic snapshots of your virtual machine without the need actually to export data outside of the AWS if you need to. Export task has completed, and notice that instantly store task also has completed. That's the result of having local file system backup destination installed in the same way as the staging space, so we don't have to write data twice in that case. Now let me restore the backup here. As you can see, I have two backups available, one that has just been created, and I can specify to which hypervisor manager I would like to restore the instance. I have only one manager actually connected, so one account, and I can optionally power on virtual machine if needed once the virtual machine has been restored. So let me initiate the restore process in this case. The restore process actually consists of two tasks. It is restore, that this step actually in our case is going to be fast. It doesn't require any data merge, and so the backups are already available on the node using the file system backup provider, but usually it would fetch backups from your external backup provider to the staging space and later initiate the import task so that data is being pumped back into the AWS account. This process may take a while, so in the meantime, let me show you another feature. So the third option actually is to mount the backup. So sometimes you would like to restore individual files, grab them directly via your browser, or copy directly from the vProtect node. So here, whenever I click, I have several options how to do that. So I can either mount file systems automatically. This means that if you have a single root file system, which is quite common using AWS instances and which are Linux based usually, and you will have the feeling that all of your file systems are mounted exactly in the same way as using the regular virtual machine. Still, you don't have to run this instance in order to retrieve the files. Now, optionally, you can specify which file systems you would like to be mounted. This would also save us some time if we are able just to track which disk is the only one responsible for keeping this file system. So if you don't use the LVM in this case, but you have additional volumes mounted to your instance, we could just briefly mount this specific file system without the need to restore all of the data. Finally, you can share drives over iSCSI. It means that if you have multiple volumes, you may want to expose them over iSCSI from the node and access them from the other instances over iSCSI protocol. So this allows you to have direct access to the block device and also helps with the Windows instances whenever you would like to preserve original permissions, Windows-based permissions from your instance. So you just need to provide appropriate IQNs of your clients that will access this specific share. In my case, I have already one mounted in here. So in the mounted backups tab, notice that I have the one mounted in the auto mode. So whenever I go to the details, notice that I have one specific image, one specific file system already mounted. Well, single because it is in the automatic mode, and I can browse through the directories and restore specific files, some configs maybe, directly to my desktop. Everything that I do also you can also see in the restore history, so notice that I have restored and mounted this backup several times. Now obviously you will not do all of your backups manually. You would like to create backup policies. So here you can notice that I have backup SLA already defined. Backup SLAs allow you to define policies and schedules and actually specify where the data needs to be stored according to which schedules. Optional, you can automatically assign your instance in the AWS. You also have the concept of tags. So based on the regular expressions matching virtual machine instances, usually, you may just stick to the common automatically generated name, but if you have such labeling in place, it would also help you to use them. Alternatively, you can use the tags assigned to your virtual machine, and either by using include or exclude rules, you may define more complex conditions where the VM, if the VM needs to be assigned to this specific policy. You can also decide if you would like just to assign new VMs or remove existing ones if they no longer match your criteria. Schedules can be defined actually, well, we have two types of schedules. We can specify specific time where you would like the backup window actually to start, so when you allow tasks to start their work. Or you can have interval based, which you decide, this is quite common for the snapshot based policies, whenever you would like to decide that you periodically would like to create snapshot between specific hours and every, let's say, 120 minutes, like it is in this example. Snapshot SLAs actually look pretty much the same. Very important aspect is actually that in your rule you don't define where to store backups because you don't export any data, but you may define how many versions, so how many snapshots, and for how many days you would like to keep your snapshots on that particular instance. Finally, recovery plans. Recovery plans are also kind of policy. In this case, policies also have their schedule, but the idea is actually to initiate the opposite action. So we would like to restore batch of your virtual machines to the specific environment, and each such recovery plan has rules. Rule basically is specific for the type of the environment where you would like to restore. So type, I mean the hypervisor type. So you may imagine that you would like to have production instances in AWS, maybe subset of these instances, or maybe some other hypervisors that we support. And this recovery plan can have a mixture of these. So you can have a rule that restore all of my production environments across all of my added hypervisor managers. I have one rule in this case. This rule has my single instance selected, and optionally, that's not obligatory, you can select schedules when you would like to invoke periodically such restore operation. If you don't assign schedules, then usually you use such recovery plan for future disaster recovery on-demand execution. With scheduled recovery, you may want rather to focus on the delete if virtual environment already exists parameter, and maybe provide some prefix to your naming convention if you would like to have all of your VMs being tested periodically, in this case, with the specific known prefix or suffix added to your name whenever you restore such VM. Otherwise, you may end up with the same VM restored multiple times and occupying unnecessary space. One very handy option in the recovery plans is that you may either select last successful or last regardless of status backup that you would like to restore. The first one is pretty much obvious. You always would like to restore just last successful backup, but the second one is strictly for the purposes for that to inform you that your backup, the last one that you at this point wanted to restore, is not present, or it is in the failure state. So it helps you to track and report such scenarios where you don't have protection in place as you would like to. Whenever you invoke the recovery plan, you actually invoke set of rules. So all of the rules that are marked as active will result in a task that is being created. Our previous restore actually has also completed now. So notice here that I have additional instance running, the one that has just appeared. I have also mentioned that vProtect supports multiple backup destinations. From the AWS perspective, you may rather focus on the other types of the storage or places where you would like to store your backups, not necessarily within the same cloud. So using vProtect, you can actually choose, well, it can be a local file system or any other file system that you allow to work also from the outside. But usually you may think rather about the object storage accessible over your dedicated network connection to your AWS account or enterprise-grade backup providers. With the object storage, we support also other cloud vendors, so like the Microsoft Azure, Google Cloud Storage, for instance, or OpenStack Swift if you have it in your local data center. And from the enterprise-grade backup providers, notice that we have also 4 different vendors, 4 different types of the backup provider available. So it's Avamar, Networker, Spectrum Protect, or NetBackup. That concludes this video. So thank you for watching.